Hello everyone, you're welcome to this channel once again. Today we have another question on finite wing and how to calculate the coefficient of lift and the induced drag coefficient. Now let's read to the following question. Consider a finite wing with an aspect ratio of 8 and a taper ratio of 0.8. The airfoil section is thin and symmetric. Calculate the lift and the induced drag coefficient for the wing when the angle of attack of 5 degrees is applied. Assume that the induced drag factor equals the lift slope, that is delta equals tau. Now let's assume we pull out all the parameters for the finite wing. We're given the aspect ratio 8, the taper ratio 0.8, the angle of attack 5 degrees, and we're told that the induced factor, which is delta, equals the tau, which is lift slope. Now, considering the finite wing, we can deduce the formula to be A equals A0 over 1 plus A0 over pi AR 1 plus tau. By slotting all the values, we can find the induced factor for the drag from the standardized graph by tracing the taper ratio 0.8 up to the curve of the taper ratio to the vertical axis, whereby we can deduce that we have 0.055 as the induced drag factor. So by slotting all the values into this particular equation, we can deduce that our A equals 4.97 per radian. Then we convert the radians to per degree by multiplying by pi over 180. That gives us 0.08678 per degree. From here, we can deduce that since A0 equals 2 pi and our trace induced drag factor equals 0.055, then we can find the coefficient of lift, which is A multiplied by angle of attack. By calculating this, we have our CL 0.4339. The next thing is to find the coefficient of drag induced, CDI, which is CL squared over pi AR. Then, since we've calculated our CL, then we can slot in the values to find the CDI. Our CDI calculated equals 0.007879 calculated. Thank you for staying tuned.